Okay, so let me see what I can do. So the obvious solution is like what I'll have to do is since since everything's sorted and what I'll have to do is to do some kind of like a binary search on a given array of integers.
Okay.
So the only thing that's like since we want to find so the complexity must be on the order of log n. The only thing that's like that comes from, I'm not sure if it's let me see how I can do the log n. Because the problem is that I see with like with kind of like my approach that I chosen right now. So in this case, let's say we have like let's say we have this element. So let's say it's going to be 8. So how many is in like 6? Okay, we'll have like 7. So in this case, we have like, let's say here we have like 7 elements. So what we'll have to do, so we'll do like a binary search. After that, we'll find like the so it's going to be 0, 1, 2, 3. So we'll check the index at check. Let me see. Check middle, kind of like middle index at first, which in my case is going to be equal, which is 3, which is going to be equal to 8, which is actually our, let's say the target is going to be also 8, which is actually
Okay.
target value. So and after that, I have to basically find some kind of like upper bound and lower bound of where it starts and where it ends. So in this case, what I can do is actually I can probably do instead of like I can actually do some kind of like a modified binary search. So let's say
Okay.
so I only have the array of integers, so there can only be integers. There cannot be like any other like elements. So
So
I
it's just,
feel like
yeah,
what I so
it's
yeah.
just
So I
integer.
feel like what yeah I see. So I feel like what I can do is like let me see. So I can do some kind of like a modified binary search. So let me copy this down here. Okay. So in this case, how many elements I have? I have 6 elements. So I have to basically, I assume that I have to, so I have to do the binary search kind of like 2 times. So the first one is to find the lower bound and the second time to find the upper bound.
Okay.
And so in order to find the lower bound, so it should basically be, so how I can do that? So let's say my target is, so in this case, my target is going to be equal to 8. Okay, so I'll have to find, let me just number them, 1, 2, 3, 4, 5. Okay, so in this case, if I start from the beginning, so I have 6. So I have 6 elements divided by 2 is going to be, I start from this one, so I'll start from 8. So let me see. So I basically have to find kind of like this thing, like which is like index 2 where equal to 7. So let me see how I can do that. Okay, so what I can do is like I can probably do something like if so for, let's say, for lower bound, I have to, so as usual we'll have like some kind of like, let's say, low and high, low like left and right, which initially,
Right.
let's say, this one's going to be equal to 0 and this one's going to be the length of my nums minus 1. And after that, the medium in this case will usually is equal to divided by 2. So the only difference, I feel like this will be like in a way how I move like left and right. So what I will do is something like if nums of middle is going to be if nums of middle is going to be equal to more if it's going to be more than my target, more or equal to my target, then I move, then kind of like change. So if it's so, let me see. So this one, if change R.
What is R? Oh, right. Okay.
Yeah. So in this case, I change my like right bound. So in this case, let me see. So in this case, if my current element that I found is going to be more or equal to the target, then I change R. Yeah. So I change R, or else in this case, if it's going to be less than otherwise, if nums that element is going to be less than let's say we have here like a 4. Oops. Let's say we have something like 3, 4, 4, 5, something like that. So in this case, if here we have 5, 6. Okay, so in this case, if we have so we check this index 3, which is going to be equal to 5. After that, we know that 5 is going to be less than the target. So that's why what we'll have to do is we'll have to change left. But here, so kind of like left should be equal to m, to the middle
Okay.
one. And here the right should be equal to m minus 1, because in this case it shouldn't be inclusive since we don't want to include this element there. So I feel like that's this kind of like how we can do for the lower bound, and for the upper bound it's going to be
right. So I guess I'll just add something in. So you're definitely on the right track. But here we pretty much end up having the same stuff as what binary search has, right? But you haven't really found, you haven't really indicated where the lower bound might be, right? So let's think of the example you have where your target is 8, and let's say you pick index 4. Just you happen to get to index 4, right?
Sure.
And let's say you wanted to try and find the very first 8 in that case, because this is just the very first one you found, right? The naive approach they could take is, oh, now that I found an 8, I can just keep going left, right? But of course, that wouldn't work out because that's a linear time complexity. So after we say that we found this first 8, what would we end up doing this to determine whether or not this is the leftmost 8, the lower bound? I think the answer to that is missing in the section of pseudocode that you wrote. Because right now we're talking about M, we're talking about R and L, but we're not really talking about what the lower bound is, right? Unless your L is going to be the lower bound at the very end. I'm not sure if that's where you were going.
I was kind of like assuming that like my lower bound is going to be M.
Okay.
I was kind of like, so in this case, I will have like this one will be running like still like let's say while L is going to be more, while L is less than R. So, and then like I'll have like something like that. So it's going to be looping. And after that, like when L is going to be more equal to R, then I will just return M. So,
but is that always true?
Let me see. So let's say we have this one. So let's say it's going to be like this example. So we have, so the first one is going to be 5. Then we know that 5 is going to be less than, so that's why we said that L is going to be M. So after that, let me go through this. So in this case, L initially 0, then R will be 6. After that, the next one, and actually I can also do the middle. Middle in this case is going to be it's going to be 3. So after that, I check the middle, which is going to be 5. 5 is going to be less than the target, so that's why I check. move the L, which is going to be equal to 3. This one still 6. This one right now is going to be equal to, so it's 3 plus 6 divided by 2, which is going to be 9. 9 divided by 2, which is going to be 4. So after that, this one is going to be equal to 4. So in this case, let me see. So in this case, I will check the 4. So I check the 4 if 4 is going to be more or equal to the target. Yes. So that's why left is still 3. This one will be 3, and we don't care about medium. In this case, left is equal to the right, so that's why kind of like we can. And so in this case, left is going to be equal to also 3. So after that, like we quit the loop and then we can return m, which is going to be 3. But let me see if there's like anything, if I have something different. Let me go over some kind of like an, let's say like another, like let's say some kind of like an H case. Let's say we still have 8, and let's say we just have like 4 elements.
I think a really easy one for this is if you just have 1, 2, 3, 4, 5, and then your target is equal to 3. You can see right away that you're never going to get index 2, right, as the result for your lower bound.
Okay, so if my target is going to be, let me see. Okay, so if my target is going to be equal to 3, so after that, like, I can probably do kind of like similar things. So let me adjust this one. So in this case, this one is going to be 0, so this one is going to be 4. So my medium one is going to be equal to 2. After that, I check, so it's going to be left. So if medium one is going to be 3, 3 is going to be more equal to 20. So 3 is going to be more equal to 3. Yes, that's true. So that's why I should change the left one. So this one is still this. So this one will be equal to 1. And after that, the medium here is going to be equal to 1.
Right. So already you know that you've gone too far, right?
Actually, this one, yeah. So in this case, this one is actually will be equal to 0.
Right. So is it helpful to think of, you know, when you get to, when you first select your mid as index 2, right? And you see that it's a 3. What if we say that that's a sort of candidate? You know, we say that this is a candidate lower bound. How does that, you know, change things?
I mean, so if you want to say that, like, if it's a candidate, so in this case, I don't need to, like, exclude this one, so I have to, okay, so I feel like that you want to kind of, like, that you imply that instead of, like, returning that element, instead of, like, let's say in my case, instead of returning, like, index 1, I have to return, like, index 2.
Well, I mean, you do need to return index 2 as the lower bound, right? Because it is the lower bound and also the upper bound.
Sure. I was kind of like thinking like that I can probably return like the index that's like before that, like let's say 1, and then I always know that this one I should that's kind of like the lower bound, and then the next one is going to be the first target value. So in this case, if we return like 1, after that I'm pretty sure that like the next one should be so the next element that's at index 2 will be equal to my target value.
Okay. We see with the example below that that doesn't work out, right? Like the middle value that you get is 0. So the next element is not your target.
Yeah, I see that. Yeah, you're right. Okay, so in this case, let me see what I can do. Okay, so in this case, so let's say this one is going to be left, this one is going to be mine.
So when you have your modified binary search, you can store additional information if you want, right?
Sure. Okay, so let me see. I can probably what I can do, like I feel like that I can probably create like another variable So let's say it's going to be my, let me just call it bound, which let's say initially will be equal to, like, doesn't matter. So let's say it's going to be just none, -1.
Okay.
So let's say it's -1. So in this case, the way I can modify it is this one. So if it's going to be equal to my, let's say it's more than equal to the target, then besides doing like R is going to be equal to medium -1, what I can also do, I can also set the bound. So in my case, the bound in this case should be equal to M. And instead of like returning like M, I can return the bound. But the only thing that actually I should probably split this one into like two conditions. So
okay.
So I can probably do something like that. So in this case, let me see. So if it's equal to the target, then I'll update my bound, and then I'll set this one to R is going to be equal to the M-1, and the same here, and R is going to be equal to the M-1, and after that I can just return the bound. So let me see if that actually works. So let's say we have left is going to be 0, then right is going to be 4, then M initially is going to be equal to 2. After that, we check once. In this case, nums at 2 is going to be equal to the target is going to be 3. Yes, so that's why I set my kind of like bound to be equal to 2. After that, I go next. In this case, so I said the left is going to be equal to 0. My right is going to be equal to M-1, which is going to be 1, and my middle is going to be 0. After that, so here my middle is going to be equal to 0. After that, what I'll have to do, I set my middle. If what's going to be my middle at, which is 0 in the 0, so it's going to be equal to 1. 1 is going to be less than the target. So that's why I have to set my left one. My left one should be okay. So here I have the problem that let me see. So let's say that okay. So I have to probably also do M+1, so something like that. So in this case, yeah. So I feel like that this one. So in this case, I have like 1, and then that's geometric because like L is already going to be equal to R. So that's why we quit the loop. Yeah. So I feel like that this one should be. So let's say this one should be fine. Let's say I'll be finding the lower bound, but let me see. Okay, so looks like that. So I have 3. After that, I'll yeah. So and then for the upper bound, it will basically be the same. Besides this.
Yeah, besides like the inversion, right?
Yeah,
I think for writing out the pseudocode portion of that, I think you pretty much would get it based on the lower bound, or you'd write it similarly. So given that, I think I'm pretty okay with going ahead and starting to write the actual code.
Okay, sure. Okay, so let me just kind of like the last thing, like let me just kind of like do like right here. So let's say if it's going to be if I'm finding the upper bound, I mean, so in this case my condition I should be equal L, and L is going to be should be M+1, so it should be something like that. Okay, so in this case, so let me copy down here. Okay. So after that, let me just call line started. Okay. Find let me just, let's say, find interval, and then it's my input. I assume that I'll have the target in nums. Nums the target.
Yep.
Nums is the array. So okay. So after that, so I assume that okay. So after that, let me just kind of like create like a helper function which is going to be called binary search. Binary search. After that, so it's going to be a set nums target, and also we'll have some kind of like a flag if it's a lower bound or upper bound.
Okay.
So in this case, let me see. So in this case, left and right is going to be equal to 0, and this one is going to be the length of my nums -1. After that, we'll have a bound which is going to be equal to -1. After that, here I'll just have like while left is going to be less than r. So here, what I will do is this one: if nums of middle, or here I can compute the middle. Middle is going to be equal to left plus divided by 2. So after that, here I'll check if nums is equal to the target. If it's equal, then I will set the bound. Bound is going to be equal to m. And let me see, like, if I can kind of like write it in a prettier way. So in this case, I have the first condition. After that, so the only difference is after that I have to. Oh, actually, it's fine. Probably I can probably write it like that, and then I can kind of like modify it. So in this case, after that, let's say we have left and right, which is going to be equal to left and m plus. So I can probably do something like that. So in this case, if so it's going to be like that. If lower, so if it's a lower, in this case, what I said is this one. So left is going to be still left, and r is going to be m -1, or else it's going to be equal to m plus 1, and this will be r. So if it's a lower, if nums is going to be more than the target, then so here the conditions will be the same. It's going to be r -1, else left is going to be m plus 1, and after that I will just return the bound. Yeah, so it should be something like that. So after that, let me call this function here. Let's say it's going to be the lower bound. Actually, I can just return this one. I can return the. It's also probably better to rename my function to call it like find bound, like let's say get bound, and I'll be calling on this one. So get bound and that and lower pouch. Okay, so it's basically I'm just calling like this function to get the lower bound and the upper bound.
Okay.
Yes, so it should be like that. So let me just go over an example to see if that actually works. So let's say, let me take an example that let's take this one for now. Let's 1, 2, 3, 4, and then my target is going to be 3. So my answer should be equal to 0, 1, 2, and 2. So in this case, when I call this function, so at first I do the lower bound, and what I have there is going to be left, right, middle. And let me just make B is going to be like my bound. this one B, initially it's -1, this one's going to be 0, this one G, 1, 2, 3, 4, 4, and this one will be equal to 2. So the initial one, so it's going to be so this one is equal to, so that's why my bound right now is going to be equal to m. M is going to be equal to 2. After that, since my lower is going to be lower is going to be true, so that's why my left is still the same, which is going to be 0, but my right one right now is going to be equal to 1, and my middle in this case will be equal to 0. After that, I go next and I check if my zero, so in this case it's going to be 1. 1 is going to be less than 3, so that's why I increase L. So it's going to be L is going to be equal to m plus 1, which is going to be 1, and it doesn't matter anymore. So that's why this one is going to be 1, 1, 1. So that's why I return 2, which is right. Then let me just quickly do the same thing for the upper bound. So initially, like, all the settings are going to be the same, and after that, like, the bound will still be 2. After that, I have the medium. So I found that index element at index 2 is going to be 3. 3 is equal to my target, which is going to be equal to 3. After that, what I will do is I will check. So in this case, my lower is going to be false. So that's why I set L to be equal to m plus 1, so it's going to be 3. All right, it's going to be 4. M in this case, after that is going to be 3 plus 4 is going to be 7. 7 divided by 2 is going to be 3. So this one's going to be 3. After that, what I have next is going to be element at index 3 is going to be 4. 4 is going to be more than equal to the more than the target. So that's why I left still the same, but I decreased the right. So right in this case is going to be equal to the m minus 1, which is going to be equal to 2, which is kind of like the end, and then I return. Yeah, so this one looks fine, and I can probably write some kind of like a test cases here.
Sure.
So let me just call some kind of like a test driver, and I can probably do, let me just import named tuple, so it will be, I think it's going to be better to test it. So then in the test driver, I'll pass my test cases. So here, so let's say I will define all my test cases going to be here. The test case is going to be just simply array of test cases, and the test case is going to be look like that. Test case is going to be named tuple of test case, and here I'll have like let's say it's going to be input. Let me call it like test input, and then the second value is going to be expected result. Expected result. So in this case, when I create it, it's going to look something like that. After that, my first one is going to be my array. So let me just, let's see, I'll have. So it should have, it should look something like that. So it's going to be the array, and then the target one. The target will be, in our case, it's going to be 2. Oh, okay. So and the target here is going to be, let's say, it's going to be 3. So in this case, and our result should be equal to 2 and 2. So
right.
Let me see. Yeah. So let me just kind of like write 1 in this case, and then I can write more to see if that works. So after that, I'll do for, I'll just complete my function test driver for I, and then I have a test case in the enumerate of test cases. And here I will call my function, which is going to define the interval. Going to be this one, and I will be calling it from. It's going to be test case. First one. Oh, actually no. It's called test case dot test input. And okay, so it's going to be like that, and after that I'll have my result, and after that I'll just do, let's say, I'll do assert result to the test case that expected result. So if it's not equal, then I would just say it's failed, then expected, what did we expect? Expected test case that expected result, but let's say got, and instead of that we got result. So after that, if it's fine, then I will just print. So then I'll just do past test case. So this is test case I, and I can also actually include the same thing here. Failed, and the name of the test case is going to be I. Yeah, so I feel this one should be fine. And after that, so in this case, the only thing that's remaining is to actually call my function. It's going to be test driver, and I call it from using test cases. Providing the test case is going to be my argument, and so got expected, yeah. So let me run it. Yeah, so it looks like it passed, so I can probably do it more.
Yeah, I'd say one test case we probably want to check out is, I'll let you write them out, and then yeah.
Okay. So in this case, let me just, like, the first one, let me just copy the one that you gave to me. So it's going to be this one. Like that. So in this case, and my target was 8. After that, let's say I'll have an empty one, and then let's say my target is going to be 3, so it's going to be -1. After that, let's say I have like everything. Let's say I have, so it's going to be 0. Then
yeah, that was the one I wanted to suggest. Just the single element.
Okay, so yeah, so in this case, let's say I have like 1, then I have like, let's say, odd number, then I have like even number of elements, then it's going to be 1, 1. Yeah, so I can probably run it. So let me just modify this second test case. So in this case, my result for the second one is going to be equal to 0, 1, 2, 3. So this one should be 3, and this one should be 4, like that. Okay, so test case 1 failed, so which is this one? So expected 4 got 4 and 4. Okay, so let me see what's the problem. So in this case, it was 5, 7, 7, 8, 8, 10, 8. So I had to return the 0, 1, 2, 3, 4, and this one. Okay. So in this case, it means that my my lower bound didn't return the right thing. So let me go over it and see like what's the problem. So it's going to be something like that. So let me see. 0, 1, 1, 2, 3, 4, 5. Okay. So initially everything is, so I'm looking for my lower bound. So let me just do it.
One thing I should point out is actually you can choose to print within the function if you want to for debugging.
Oh,
if
okay.
It makes more for you. It's up to you.
Okay, yeah. So in this case, it's kind of easier. So let me just print it here. Okay, so let me see from the beginning. So in this case, we have like actually, let me just go over it like that again. So in this case, we have an array, and then this is going to be 5. So my middle one is going to be initially 2, which is, I know for sure that my my middle one is going to be, so it's index 2, so that's why 7 is going to be less than 8. Let me just kind of like the target here. It's going to be 8. So 7 is going to be less than 8. So that's why I move my left one. So it's 94. So this 5 will be equal to 3. So 3, 5, and so it's going to be 4. this one is going to be 4. This one is still -1. After that, I go to the next one. So it's going to be 3, 5, 3, 5, and 4. So in this case, my middle one is going to be 8. My middle is going to be 4, which is 8. So that's why I set this one. I set my bound is equal to 4. After that, I check. So if it's a lower, yeah, it's a lower one. So that's why left is going to be still be the same, and my right one is going to be. Oh, okay, I see. And my right one in this case, it will be also 3. Okay, so that's an issue. Okay, so in this case, let me see what I can do, how I can fix it. So it means it's when it's equal to, so when it was, okay, so it's when it was 4. After that, when I check it, so I know that, okay, so let me see, so in this case, I know that like my 3, at that moment, I know that at index 4 is going to be equal to the 8. Probably, so do I need actually, so if I do not increment 1 here and like decrement 1 here and increment 1 here, maybe I should just do like m. So let's see. So in this case, I had like 3. After that, I had like so my right one. If I didn't decrement, so in this case, I had like my right is going to be equal to, it's going to be 4. So in this case, after that, I'll have like 3 plus 4 is going to be equal to 7. So it's going to be 3. And after that, I will check the 3, which is going to be kind of like I would set the bound equal to 3. And after that, what I will do is, let me see. So in this case, if it's a lower one, yes, low. So that's why this one is 3, and this one will become 3. So I feel like what I can do is like I don't need to decrement and increment it. So let me see if it's actually going to work for previous examples. So my previous example was like 1, 2, 3, 4, and 5, whereas target was 3. So in this case, let's say initially it's like 0 and 4. So in my middle one is going to be 2. Then I check the 2. 2 is going to be my target one. Yes. So that's why I would set. So this one is a lower one. Yes, it's a lower one. So that's why I would set my left. Let me see. My left still going to be equal to 0, but my right one is going to be equal to 2 in this case. And my middle one after that is going to be equal to 1. Okay. So and after that, like what I will have, like so I have like 0 to 1, and after that I go next, and next iteration is going to be 1. I know it's a less, so that's why I will just increment. Yeah. So I feel like this one should be fine, so I can probably run it.
Okay.
Okay. Actually, so I feel like
Did it only run one of the test cases? Oh, I see. That was supposed to be the infinite loop, right?
Yeah. So there's an infinite loop.
So, yeah, because you're not going to really be able to hit the terminating condition, right? When you have stuff equal. So,
yeah.
Let's think of the test case at the bottom here. Maybe this helps define what the issue might be. So, in this test case, with the old code that you had, before when you had the m-1, m+1, what goes wrong for this one? It's the exact same situation, right, as test case 2.
Yeah. Okay. So for this one, so in this case, let me see. So in this case, my left one, so in this case, is going to be 0. My right one is going to be equal to Actually, this one, okay, so, okay, see. So in this case, my left one and my right one, both of them are going to be equal to 0. So that's why, so if it's basically, so if there's like, for like this particular example, I just have like one element, so that's why I won't even like enter the loop, and I will just return -1. So I feel like what, in this case, let me see if I can modify like my condition in a while statement. So like, let's say if it's while left is going to be less or equal to the right. So in this case, if left is equal to is less or equal to the right, then I'll have like my left, my right, and my m. And after that, like I would check what's going to be my medium. My medium is going to be 1. 1 is equal to my target. Yes. So that's why I check this one is a lower one. Yes, it's a lower one. So that's why this one is going to be still 0. After that, my right is going to be equal to -1, which is kind of like 0 is going to be more than r. So that's why I would just return 0. And for this, it's kind of like similar thing for like upper one. For upper, I'll have like here is going to be 1, here is going to be 0, and L is going to be still. Yeah, so I feel like this should fix this condition, like if L is going to be less than or equal to the right, it should fix this thing. So let me try it. Yeah.
Cool. Yeah, I guess that looks good to me, and we can just go with that. So I guess I could just go over some of the feedback for how this went. I think overall this went, really well, because really the only thing I'm looking for is, can you write bug-free code? And I think the 2 problems you did showed that. There was just a small little portion where the less than or equal to, I guess, took a while. But I guess reading over the notes, I think it was good that you clarified the assumptions for Q1. You're pretty quick with figuring out the problem-solving approach. So it kind of seemed like you did the problem before versus, Q2. And the code was, really quick to come out, right? Similarly for question 2, got the initial, idea out. And then you did go through multiple ideas, to try and kind of figure it out, which is good, instead of just kind of saying, oh, I have no idea. And yeah, like I mentioned, quick to code out, also clean, solid communication. And I really liked the, the really meticulous testing and explanation of code. The one thing I would say is probably helpful is when you're stuck, it's okay to maybe take a pause in what you're saying. There was a part, especially when you were trying to figure out, how to find the lower bound, that you kind of, kept on going, and I wanted to let you go because it seemed like maybe you would get something, right? So I didn't want to go ahead and give a hint right off the bat. But then I kind of, noticed you were going in loops. So I just said, oh, this is where I should, mention the candidate idea. That took a couple of, tries to kind of nudge you in that direction, but you got it. And then as soon as you got how the candidate works, then the code came out, really quickly, right? Yeah, so I think it was definitely solid. Yeah, because the coding part is like the most important, right? And that part went really well.
Okay, yeah. Thank you very much for the interview.
Cool. Did you have any questions for me?